So, good afternoon, and welcome to the Japanese Symposium on Open LLMs. So, I'm Sadao KUROHASHI, Director General of NII, and also Director of NII-LLMC. So, as a first speaker of this session, I'd like to share the background and the motivation of our activity called LLM-jp and NII-LLMC. So building a sovereign LLM ecosystem through open and team science. So computational language understanding has long been one of our dreams, and something that exists only in science fiction. But suddenly, with the emergence of ChatGPT, that dream became reality almost overnight. And the breakthrough is having an enormous impact on humanities. And since the release of ChatGPT, LLM development has accelerated and continued steadily. GPT-4 achieved high score on expert level exams and also multi-modal ability, function calling, mixture of expert model, and the retrieval augmented generation, and very long context model, and reasoning model, and deep research mode. And recently, a wave of major models has been released: Llama 4, QN3, Claude 4, GPT-5, and Gemini 3 last week. So far, so good. But we have also concerns about LLMs. So LLM research and development was monopolized by a few organizations and conducted in a closed manner. When GPT-4 was released, this was exactly the situation. And for the strongest models today, nothing has really changed. But the behavior of LLMs, including their language understanding and multilingual abilities, remains unexplained, essentially a black box. Although some leading companies such as Meta, Alibaba, DeepSeek are gradually adopting open source strategies, their training data remains closed. On the other hand, current models still suffer from issues such as hallucinations and biases. We also have another concern: the English dominant. FineWeb and FineWeb 2, the most widely used web corpus containing about 20 trillion tokens, contains only 1.4% Japanese text, resulting in weaker performance in Japanese compared to English. So based on these concerns and consideration, we started the open and team science type activity called LLM-jp. Let's develop an open and Japanese competent LLM, try to understand mechanism of LLMs. And all the resultant models, data, tools, technical documents will be open to the public, including the process of discussion and failures. Anyone who agrees with this purpose can participate. We started this activity in May 2023, just as a volunteer study group of 30 NLP researchers. But actually, it expanded rapidly, and now more than 2,500 people are participating to this activity. Not only natural language processing researchers, computer vision, high-performance computing, and medical doctors, lawyers, very wide range of people are attending. And in 2023, we tried small model training using MDX, computational environment located in University of Tokyo. And also we tried the investigation of training of 175 billion model using ABCI under METI, Ministry of Economy, Trade and Industry. And 2024 April, we launched LLM R&D Center at NII. And we also started the training of 173 billion model using ZENIAC. ZENIAC was a METI-supported program. We believe LLM-jp activity is one of the early attempts at building a fully open large language model. But of course, there are several similar activities around the world, including OLMO. We can learn a lot from those efforts because they are open. So the openness is extremely important. So large language model R&D is a big science. So we have to prepare very huge corpora, and we also need a large scale computational infrastructure and know-how of parallel computation. And we also need the tuning data and evaluation data. Furthermore, we have to care safety, multimodal, real-world interaction, including robotics, and also the principal elucidation, and speech dialogue, and science domain application. And I can proudly say the best experts in Japan are leading these working groups. And plus, we hired, LLM Center hired about 20 project researchers, and also we hired a research assistant, about 50 research assistants. So they are basically PhD students of universities, and we have a nice collaboration, nice synergy. For example, the PhD student of Tohoku University worked together with the professor of University of Tokyo and also the researcher at NII-LLMC. And did a good research and had a good publication in a top conference. So actually, the majority of the LLMC budget goes to computational resources. And securing computational resources is one of the most difficult and painful challenges for us. So last year, we used 100 nodes of H100 GPUs on Sakura Internet, a major Japanese cloud provider. And also we used the 16 nodes of A100 GPUs on MDX. And this year, we use about 20 nodes of H200 GPUs on ABCI, and we also continue to use MDX. So while this is much, much smaller than what big tech companies have, it is exceptionally larger it is exceptionally large for academia. And I really thank the efforts of Ministry of Education, Culture, Sports, Science, and Technology. Okay, using those computational resources, we trained several models. And this is the performance of our models. So x-axis is trained token size. So we trained the models using 2.1 trillion tokens so far. And half of them are Japanese text. And half of them are mainly English and also include Chinese, Korean, and some other languages. And y-axis is a benchmark, quality, the benchmark score, which is of LLM-jp eval, which is also developed by LLM-jp activity. So each color corresponds to the parameter size, and the bigger size is better, basically. But we observed 172 billion model performance is saturated. And current flagship model, our flagship model is 8 by 13 billion MOE model. So this is the result of pre-training. And after mid-training and post-training, actually the performance of 8 by 13 billion model goes up to somewhere here. And pink dotted line is the performance of GPT 3.5. And the gray dotted line is GPT-4. So that means our model is better than GPT-4 already. And actually, LLM-jp eval is a relatively simple tasks to monitor the learning process. But even when we use a more realistic and challenging benchmark, MT bench, actually our performance is better than GPT-4, but less than GPT-4o currently. But we are actually paying strong attention to safety issue. And we have a tight collaboration with AI Safety Institute Japan, and we constructed a data set for safety called Answer Carefully. And using this data set for the safety aspect training, actually our performance is already better than GPT-4 and GPT-4o. Okay, so this is the model, current model training schedule. And now we are using 10 trillion tokens. And we are as a dense model, we are training both 8 billion models and 32 billion model. And they are under training and will be completed in January or March. And we are also planning to construct a MOE model. Smaller model, active parameter 3 billion, will start in December. And a bigger model, active parameter size 22 billion, training will start maybe next January. But actually, it takes 6 months, 6 months, even we use 64 H200 nodes. So maybe we can release this model next June or July or sometime. And we are also engaging in data access negotiation to secure more valuable data set. One interesting data set is classical Japanese materials of National Institute of Japanese Literature, 3 million images and OCR text pairs. We are already using this data to train the model, and we expect our new model will somehow interpret the Japanese historical materials. And we also obtained government publications from National Diet Library. And also we are negotiating with publishers who have textbook data sets. I mean, elementary school or junior high or high school textbook. And they are very, of course, valuable for the educational use of LLM, I believe. Okay, so let me conclude my introductory talk with a brief message. So the realization of computational language understanding is already having a profound impact on our society. And it will continue to reshape it. So this impact is far too great to be handled by a small number of private organizations, especially in a closed manner. So this is a challenge that we must confront together. To do so, our efforts must be open, transparent, and grounded in team science. Thank you for your attention.